Okay, close your eyes for just a second. I want you to imagine absolute, total darkness. No light, no sound, no stars, not even empty space. Just the void. Okay, now open them. In this explainer, we're going to take a cinematic journey starting from that unimaginable darkness of the early universe, all the way to the staggering complexity of human consciousness. We are tracing 13.8 billion years of history to ask what is arguably the most profound question of our time. And that poses the ultimate mystery. Is everything we see, touch, and feel a fundamental physical reality, or is our universe actually a grand computed system? Let's dive right in and look at the evidence our cosmos has left behind for us. All right, let's kick things off with Section 1, the cosmic boot sequence. So our story actually begins with the ultimate enigma, nothing. But here's the thing. In modern cosmology, nothing isn't exactly empty. It actually has weight. It's a pre-state, kind of like a quantum vacuum or a singularity that exists before any familiar matter does. Imagine these invisible rippling fields and fluctuating light. If we're looking at the universe as a simulation, you can think of this pre-state as the boot-up phase of a massive computer program. It's the exact moment where the fundamental constants and the rules of the cosmic code are about to be written. Boom! 0 seconds in, we get the Big Bang. Within mere fractions of a second, the cosmic system sets up its basic rules, spawning quarks and photons. Fast forward about 380,000 years, and the universe finally cools down enough to compile its very first simple data structure, hydrogen atoms. And those atoms leave behind a faint relic glow that we can still detect today, which we call the cosmic microwave background. Moving right along to Section 2, building the universe's hardware. After those first atoms formed, the universe entered the cosmic dark ages. I mean, it was completely filled with diffuse hydrogen gas, but there was absolutely no light. Then, gravity went to work. It started pulling all this gas together until the intense pressure ignited the very first brilliant stars and proto-galaxies. Imagine those first stars turning on one by one, almost like blinking indicator lights in a dark, unimaginably vast cosmic server room. And these stars, they weren't just pretty lights, they were absolute cosmic engines. We're talking massive foundries forging heavier elements like carbon, oxygen, silicon, and iron. Think about that for a second. The iron in your blood right now was literally forged in the explosive death of a star. This progression of stars is basically manufacturing the physical hardware of our potential simulation, creating all the raw ingredients for future chemistry. Now zooming in on a young stellar disk of dust and gas, violent collisions of rock form a molten world. As it cools down, our blue planet emerges. Earth develops this complex, layered structure. You've got the core, mantle, and crust, along with active geophysics, oceans, and an atmosphere. You can really think of Earth's complex geology as our operating system environment. It's stable, it's running in the background, and it is fully prepped to support the complex biological processes that are just about to launch. Which brings us to Section 3, the biological algorithm. Down in the incredibly harsh hydrothermal vents of early Earth, a rapid cascade of complexity kicks off. We go from single cells to dinosaurs to primates. When you step back and look at it, biology is essentially an incredibly advanced algorithm. It's the universe computing via self-replicating physical matter, constantly adapting, constantly evolving. Next up, Section 4, software of the mind. This is where things get really wild. The biological brain sparked something totally revolutionary. Early humans moved from painting on cave walls to literally inventing mathematics. Just realize what this means for a second. Logic and linguistics are abstract software layers built right on top of our biology. Through us, the universe has actually developed the capacity to model itself. It's as if reality is finally waking up to study its own code. And humanity's attempt to interpret this cosmic program basically took two really fascinating paths. On one hand, we used rich symbolic mythology, think cosmic eggs and massive world trees, to emotionally interpret the universe. On the other hand, we developed modern quantitative science to mathematically map it. Both of these are high-level layers of human culture, just trying to explain the grand system that we find ourselves inside. And we didn't just stop at ancient myths and basic math. We organized ourselves into wildly complex networks, nations, economies, legal systems. Our search for truth completely fragmented into specialized academic disciplines. Fields like physics, computer science, linguistics, and even theology act as specialized subprograms. They're like separate, dedicated modules inspecting one tiny, highly specific aspects of reality's overarching structure. Let's zoom back out for Section 5, Cosmology and the Multiverse. When our best scientific modules look deep into the universe, they find mysteries that simply don't fit the visible code. They propose things like dark matter, cosmic inflation, and these wildly speculative multiverses, bubble universes, and branching quantum histories. These bold, unproven attempts suggest that our reality is vastly more layered than we ever imagined. And that leads us to the big one, Section 6, the simulation question. We now have to confront the simulation hypothesis. This is the profound speculation that our entire cosmos, all 13.8 billion years of its history, all of its physical laws, might actually be running on a higher-level computational substrate. Is someone or something observing or even editing the universe from the outside? If we actually entertain this hypothesis, some massive questions pop up. First off, look at the fine-tuning of the universe. Is the incredibly precise structure of our physical laws evidence of intelligent design, like a programmer who set the exact parameters needed for life to exist? Or is it simply the result of cosmic natural selection across an infinite multiverse? Furthermore, what about math? As we discussed earlier, we use math to perfectly describe the universe. But are these mathematical regularities we keep discovering merely descriptive tools that we invented, or are they actual hints of an underlying source code? Is physics really just the process of reverse engineering the engine that we are running inside? And finally, what about us? Could our deeply felt consciousness, our art, our cultures, and our myths simply be emergent behavior? Just complex outputs running inside a vast, unfathomable simulation? Now, it is absolutely crucial to remember that right now, this remains a profound speculation, not a proven conclusion. The hard truth is that we currently have no decisive way to prove or disprove the simulation hypothesis. Why? Because our best tools, physics, computer science, philosophy, can brilliantly map the patterns of reality, but they are entirely trapped inside the very system they are trying to analyze. You literally can't use a ruler from inside the simulation to measure the computer sitting on the outside. But look, whether we exist in fundamental base reality or we're living inside an unimaginably advanced simulation, this is our cosmos. It's a masterpiece of unfolding complexity, taking us from empty darkness to the human mind. The real question isn't just about the true nature of our reality, but our role within it. Given all of this incredible, hard-won complexity, what will we choose to build in it next?